All right, today we're going to talk about end behavior and synthetic substitution. Do a quick little review. When you're graphing a function, you can have the ends of your function. One can go up to the right, the other down to the left. You could have them go down to the right and up and to the left. These are odd degree. Okay. You could also have both ends of your function going up, or both ends of your function going down. These are even degrees. So when we're talking about end behavior, we're talking about what the ends of the function are doing. Okay? When you have this one, your leading coefficient is positive. This one here, your leading coefficient is negative. This one here, your leading coefficient is positive. This one, your leading coefficient is negative. So let's do an example. Okay, problem number one. We'll say f of x equals 3x to the fourth minus 2x cubed plus whatever else comes along. It doesn't really matter. We're really focused on this one here. Okay, looking at this number here, that's an even degree. So we know that both ends are going up or both ends are going down. This one here is a leading coefficient, which is positive. So I know that my graph, one end is going to go up here, the other end is going to go up here. So let's describe what this is doing right here. As x approaches positive infinity, so as your x's are getting larger, your y's are also approaching positive infinity. As you put x into the equation, your x's are getting bigger, your y's coming out of the equation are also getting bigger. This end over here, as x approaches negative infinity, so your x's are getting smaller, your y's are approaching positive infinity. As your x's are getting smaller, your y's are increasing. Okay, example number two. F of x equals 8x to the 7th plus 3x to the 5th plus 1. It's an odd degree. Which means that our ends are going in opposite directions. But right here we got a leading coefficient which is positive. So I know that one end of my graph is going up and to the right. The other end of the graph is going down and to the left. So this description is going to be the same as the previous example. As x approaches positive infinity, y is also going to approach positive infinity. Okay, your hours going up, so your y's are getting bigger. This one over here, as x approaches negative infinity, your y's are getting smaller. Your y's are going to approach negative infinity. Okay, so there's a quick review on end behavior. Now let's talk about synthetic substitution. It's a way to substitute a number into a function and find out what that result would be. So remember, these have to be written in descending order, and we have to put a place for each exponent. So this is in the squared position, this is in the x to the first position, this is in the constant position. When x equals 2, that means 2 goes out here. This number comes down, 4. We multiply 2 times 4 is 8, and we write that result here. And we add these up, 8 plus 3 is 11. 2 times 11, we just go do the same step now. 2 times 11 is 22. Negative 7 plus 22 is 15. So there's my final answer. So when x is 2, my answer is going to be 15. Let's try another one. Okay, they're already written in descending order, but if you notice, I don't have anything for an x squared position. So this goes in for the x cubed position. This goes in for the squared position. That's x to the first. That's your constant. Drop the 4 out here. Bring this number down. Okay, and then we just go through the process. 4 times 3 is 12. Add these numbers up. 12. 4 times 12 is 48. Negative 2 plus 48 is 46. 4 times 46, which is 184. 9 plus 184 is 193. So when I substitute 4 into this equation, my answer is 193. So f of 4 is equal to 193. So like that. All right, let's try our next one here. 5 goes in for the 5th power. Nothing goes in for the 4th power. Negative 2 goes in for the 3rd power. 0 goes in for the 2nd power. 3 goes in for the 1st power. And a 0 goes in for the constant. X is 2. We're going to put that outside. Okay, you need a placeholder for every position all the way down to the constant. This number comes down. We just start our process. 2 times 5 is 10. Add these. 2 times 10 is 20. Add these. 2 times 18 is 36. Add these. 2 times 36 is 72. Add these. 2 times 75 is 150. Add the final one here. And there's our answer. So the function when x is equal to 2 is equal to 150. Okay, hope you found this video informative, and I'll see you on the next video.